Hi, and welcome to another Hopper quick start video. This one's to show you how to get this Featherwing, NeoPixel Featherwing from Adafruit up and running. It's feather form factor, so if you put pins in it, it wants to sit on top of another feather board. So even though it's a Raspberry Pi Pico compatible board, device, it needs to be in the feather form factor, which is not the same pinout. So this is an example of a feather form factor RP2040 board from Adafruit. And that's actually the one I'm going to be using today. So let's switch to that. Okay, there we go. Let me get out of this, it's distracting. So the pins on my NeoPixel, pins and sockets on my Adafruit board, and let's just plug them together, no problem. And then plug them into their serial port. And there we go, we're ready to work. Okay, so in the development environment for Hopper, there's my sample. To use the driver, you just have to do users like that, and it'll include all the other files you need. However, there's a trick to defining the board. So most of the time, you're just going to define a Raspberry Pi Pico, but they don't have RGB built in. I did this initially for the built-in LEDs on the boards. So if I try and build now with F7, all the shortcut keys on the menu, I get an error message. To use MCU unit, target the board. We need to target a board. Okay, so we go in here and we go, oh, well, I don't know what board it is. And you try and target the wrong board. So we go here and find, say, the wrong board and then try and build again. We're going to get error messages. So it's going to say here, NeoPixel length not defined. So it doesn't know what NeoPixel length is. So obviously you need to define the right board. So let's do that. So if we go into where that was and we look through here, we should be able to find our Adafruit board in here somewhere. There we go. Adafruit Feather RP2040. And so that's the trickiest part about getting up and running. So if I compile now, bottom of the screen, it's successfully built it. Now, to initialize it, whenever you include a device driver from the devices folder, you just go and look in the devices folder for the device you're interested in. You should recognize the name. Each of them is actually the unit device driver, so that you can generically refer to it from elsewhere in the code. So that's what this device driver begin is. So that's what you do to initialize it. So let's first demonstrate this device driver drives this device in two different ways. The most common way to drive NeoPixel strings is as a string. So you've got from 0 to the length of the string and you're lighting up the pixels just like that with a little time delay in between. And I've got sort of pseudo randomization here. So let's see what happens when I run this. So build it and then launch into my debugger with F5. When the screen changes to green, we're in the debugger. And then just F5 to run. And there we go. So I put this on the dimmest setting. It's on like brightness 1. So we can actually go, you can navigate through and find, so if I control C here, and we go and navigate down. So if you wanted to ever address that and make it brighter, it's just in the driver here. You just set the brightness to a bigger number than 1. But in terms of trying to make it come out decently on the video, I had to really scale it back. These things are really bright. Anyway, in addition to be able to just address it as a string of pixels randomly, like you're doing lights in a display, I decided it'd be handy also with these kinds of devices to treat them like a display driver. So let's do that as well. So if I treat it as a display driver, then I can use all my display driver functionality. I can draw rectangles and text. I can, well, it's not big enough to draw text really, but I could draw text and rectangles and that sort of thing. And if we had a bigger matrix, it would make more sense. When you're driving with the NeoPixels, you've got 24-bit color. And when you're using the built-in Hopper display stuff, you've got 12-bit color. So 4 in each channel, 4 bits in each channel. And that's what this is down here. So let's do that, build that again, and load it into the debugger, and we'll run. So now we're going to get a short little display of the random pixels, and then it's going to go through using the graphics functions. right? So let's Control C to stop the debugger. And I'm going to put a breakpoint over here and a breakpoint over here, F5 again. We're going to stop on our debugger. So it drew two little rectangles, one inside the other. Let's see if I can fix the lighting a bit. Yeah, sorted. So you can see a red rectangle and a blue rectangle, one inside the other. Yeah, that's what the port's for. Okay. So I'm in the debugger and I'm about to draw a yellow cross. So let's see what that looks like. F10 to step over it. I've got a yellow cross drawn over my red and white rectangles. And then now the next instruction is to invert. So inverting yellow gives us blue, some shade of blue. Anyway, now let's draw a blue rectangle around a yellow rectangle like that. And now we're going to draw a green cross. And yeah, you can hardly see that that's green in this video. Very sad. Let's see what so if I invert it, what colors are going to look like. Invert the green. Yeah, now you can sort of see it. It's sort of nothing like that color on the screen, but you get the idea. It's hard to make videos of this stuff. They're very, very bright. Anyway, that's how you get this thing up and running. So it's basically 2 lines of code. So you just need to know 2 things. Make sure you choose the correct board, because the pins line up between this board and this device. And it knows because it's got a predefined pin for where's the data pin, and then you include the device from the devices, and then you call begin here, and then you can use all the regular functionality for NeoPixels or for the display driver. So either of them will work. You can choose how you want to drive it. Anyhow, thank you for watching, and I look forward to your feedback in the comments.